From this video, our course will leave the consumer's problem and turn to model the firm's decisions. By building a model of the firm and its production decisions, we will be able to derive supply functions based on these decisions. We will also be able to start modeling interactions between firms in the environment with competition. Generally speaking, we use the term firm to refer to an organization that converts input into outputs, that is, sells on the market. In real life, there are many different types of firms. One way to characterize them is to separate them by ownership. There are private firms, which are owned by private individuals and organizations to make profit. These firms' ownership may or may not be traded in public markets such as New York Stock Exchange, but they're primarily owned by private entities to pursue profits. There are also public firms that are owned by governments. In the US, we have Amtrak, the public television station PBS, public radio NPR, and state universities. We also have nonprofit organizations. This includes all types of charities, colleges, religious organizations, and foundations. These entities may not pursue monetary profit, but they all have some objective or mission that they strive to advance. Our theory in the course introduces the classical theory of the firm, which focuses on the private firms that pursue profits. But this framework can be used as a foundation to model other forms of organizations with objectives beyond profits. Within the category of private for-profit firms, there are many different types of ownerships. We can have sole proprietorship, we have general partnership, and we have corporations. These different categories involve different regulations, and they provide different incentives for their managers. So these differences are very important in law and economics that studies corporate law, taxation, or bankruptcy, and also very important in economics of management or the field of corporate finance. But for this course, we're going to abstract away from all these complexities and only model a firm as if it is a one-person operation. This approach provides some simplest possible model, and we can explore what the model can teach us. In our model, we will consider a firm whose sole objective is to maximize its profit. And the profit is a very simple object. It is just the revenue of the firm minus the cost. That's it. To break this down a little bit further, the revenue is also very simple. It is just price times quantity. For instance, if I sell cupcakes at the price of $2 each, and I sold 5 of them, then my revenue will be $10. And it cost me $8 to make them, then my profit will be $2. That's it. If the firm chooses to put in more inputs, it will produce more output. But then that will consequently increase its revenue, but it also incurs higher cost. So how does the firm make optimal choices to maximize its profit? In addition, if the firm is large enough relative to its market, then as the firm produces more output, the market price may also go down along a demand curve. That will put extra downward pressure on the revenue. This further complicates the trade-off. So how do we start to think about this? Well, model will certainly help. It turns out that the complicated piece in the model is actually the cost part, because we need to describe how the cost would increase as the output increases in a reasonable way. So where does cost come from? It comes from the cost to purchase inputs. For example, a restaurant needs to pay wages, material, utilities, and the facility, at the very least. So in order to model how the output relates to cost, we need to first model how the inputs relate to output. This is what we call technology in the classical economics theory of the firm. In this section, we will discuss how to model technology. Then, in the next two sections, we'll turn to discuss how to model costs and then the profit maximization problem for the firm. Although the context is very different, you will see that many modeling elements that we got introduced in the consumer choice problem will reappear here. Now let's get into the model of production technology. Firms use all kinds of inputs in production, but in general, we can categorize them into three major types: capital, labor, and materials. Capital refers to long-lived inputs that can be used repeatedly in the production process. Think about land, buildings, tools, and equipments. Labor refers to hours of work provided by employees. This includes all types of labor inputs at different skill levels. Material refers to all inputs that are consumed or incorporated in the production process. You can think about power, internet, metal that goes into making a cooking pot, and the material may be raw goods or processed products. All these types of inputs are very important, but for the simplicity of the model and our analysis, we will mostly focus on two types of inputs: capital, denoted by K, and labor, denoted by L. The essential structure of the model can be generalized to three or more inputs, for instance, material and other types, and the intuition remains largely the same. In the classical economic theory, the firm is considered as a very simple black box that takes input in on one end and then just churns out output on the other end. This is clearly a very limited view that ignores many nuances inside organizations about incentives, politics, power, and hierarchy. The field of organizational economics specializes in modeling and understanding these nuances in detail. But for many applications, a stick-figure black box approach will suffice, and this is the view we're going to take in this course, although it is important to recognize the limitations of this approach. Now, once we take this black box view of production, it becomes very natural to just adopt a function to describe the relationship between the inputs and the outputs. In some sense, this is exactly what functions do: arguments in and the value of the function out. A function that maps the inputs into the output is called a production function. In general, if we think about a production process that uses capital and labor to produce an output, then the production function will tell us the quantity of output that will be produced if we put in a certain amount of capital and a certain amount of labor. For example, if we think about UPS that delivers packages, the capital could be the number of trucks, warehouses, and airplanes. On the other hand, labor may be the total number of hours hired for drivers, managers, warehouse workers, etc., etc. Certainly, some inputs are more adjustable than others. For instance, to cope with the surge in businesses in the holiday season, UPS may be able to hire more temporary employees to ramp up the labor input. But it is very difficult to adjust the number of warehouses or their sizes to match the level of business. If UPS expected the development of e-commerce and online shopping, then they can certainly ramp up their capital by purchasing more trucks, building more warehouses, renting more airplanes to fly more routes, etc., etc. But all these adjustments take time. For short-term changes, such as the surge in business during holiday seasons, or for unexpected lockdown stay-home orders, the degree to which the UPS can adjust their capital level is very limited. Economists use this intuition to carve out two different types of scenarios for the benefit of analysis. The term short run refers to a scenario where the firm cannot freely adjust all of its inputs. For instance, a firm may be able to adjust the level of labor input, but not capital. To the opposite, the term long run refers to the alternative scenario where all inputs are adjustable. These concepts are related to the length of time, but they are not notions that are tied down to a particular time frame. For instance, the time needed to reconfigure the level of capital and labor for a food stand is very different from the time needed to adjust the level of all the inputs for a firm that produces rockets. Perhaps 1 month will be a long run for the food stand, but it will be 5 years for the rocket manufacturer. The short run and long run notions are very much industry and context dependent, and we should not think of them as a clear separation in terms of time. Here's an example of the limited ability to adjust capital. Around 2010, China built many high-speed passenger trains that run across the country. They are primarily designed for carrying passengers, but during shopping frenzies promoted by e-commerce giants in China, the usual shipping capacity just cannot cope with the need. And part of the adjustment strategy to increase capital during the surge in demand is to actually rent these bullet trains to ship packages. It does stretch out the capital a little bit, but absolutely not in the most efficient way. I would like to note that labor is not always more adjustable than capital, although it is the way we're describing them in these examples. Many organizations are restricted in their ability to adjust labor inputs. Law firms and accounting firms have long-term partnership agreements. Public schools in the US and universities have long-term tenure contracts. Some firms have labor unions. All these arrangements limit the organization's ability to hire or fire people at will as their need for business goes up and down. So in some cases, it may be the case that capital can be more adjustable than labor. But to fix ideas throughout our course, we will suppose that capital is fixed and labor is more adjustable. The reason to introduce the notion of short run and long run is to allow us to analyze each scenario separately. In the next 2 videos, we will discuss each of them in turn.